All right. This is not. I mean, I don't know. I think doing math is always exciting, but when we're doing problems like this, is not a lesson. This is just like doing problems that we already know. So it might not be extremely exciting. There's only one topic that we have not talked about, and that's the difference quotient. So that's this one. When we get to it, we'll talk about it. So first and foremost, these are not notes. We're just going over problems, over stuff that we supposedly already know from the summer. So the first question says, find the domain of the following function, and I have a function. So to find the domain of any function, guys, all that means is where is this function defined? For what x values is this function defined? So you're defined as long as you do not divide by a zero. Cool or not cool? So all I do is I focus on the denominator and I go, as long as this guy's not zero, and you can do, there's two ways to do it. You can do like difference of squares, x plus 2, x minus 2 equals 0. What makes that true? Well, if x is negative 2, negative 2 plus 2 is 0. And if x is 2. So these are numbers that you cannot be. Or you could have also done it like move the 4 to the other side. X squared equals 4, square root, x equals plus minus 2. It doesn't matter how you do it. Both of those are correct. These are values that you cannot be. So yesterday when I was doing this, I did a number line for my domain, and I went negative 2, and I went 2, so you can see how they did the interval notation. And so you read a graph left to right. So my domain is all real numbers except negative 2, so you can't be negative 2. And then all real numbers between negative 2 and 2 except 2, and then all real numbers after that. So how do I do it in interval notation? From negative infinity all the way until I hit negative 2, but not including negative 2, so that's why we put a parenthesis. Does that make sense? And then union from negative 2 all the way until you hit 2, and then union again, and I'm sorry that I'm bending down right here like that, from 2 all the way to infinity. So I look for that answer, and I believe it's letter C. Did that make sense, guys? And that's all we're doing. Remember, these are not notes, so if something's not making sense, we need to go and talk about like the underlying issue, like the actual notes. You know what I mean? So this is interval notation, so these are not notes. We're just solving it. Question number 2. So this individual got it correct. Let's see why. We have a square root function in the numerator. Remember that the square root function looks like this. And notice if I tell you that f of x is square root of x, you would have graphed that. That's a parent function. And you would have said x is greater than or equal to 0. So what does that mean? That means the inside expression, the x plus 3, must be greater than or equal to 0 because you can't have negative numbers inside that square root. Does that make sense? So, I'll say, does that make sense, guys, or no? Yes. You can't do square root of negative 1 because that's I, and we're not talking about imaginary. I want so the expression x plus 3 must always be greater than or equal to 0 if I want it to be a real number. Does that make sense? So I just move the 3 to the other side. I get x is greater than or equal to negative 3, but I have a denominator. And remember, there's one number you can't divide by. You can't divide by 0. So what number will give me a 0 in the denominator? 5. X cannot equal 5. If I wanted to write my domain, you could write it like that, x greater than negative 3, but it cannot equal 5. But they wrote it in interval notation. So here's how you do it. I start at negative 3, and you can be negative 3, so that's why I put a bracket. And I'm going to go all the way until I hit 5. And you cannot be 5, so parenthesis. And then union, and then 5 all the way to positive infinity. I think sometimes it helps to do a number line. At least it helped my former students in the past. So here's negative 3. You can be negative 3, but you cannot be 5. And then you can be forever 5. See, so negative 3 to 5 with a parenthesis on it, 5 to infinity. Does that make sense, guys? Yes. You can't divide by 0. So what makes x minus 5 0? 5. If I plug in x equals 5, 5 minus 5 equals 0, and you can't have a 0 in the denominator. So you cannot. If you have a 0 in the denominator, you're undefined. I mean, if you figure out a way how to do it, then you win the Nobel Prize. You can't do it. It's not possible. I'm not saying you can't get a Nobel Prize. You can because you're very smart. But you cannot divide by 0. It's undefined. Because this one has the square root in the numerator. In this numerator, x plus 5, that's a linear expression. X plus 5 has all real numbers for domain. But in this numerator, I have a square root. you can't have all real numbers because that's not my domain for square root. My expression x plus 3 better be greater than or equal to 0. So that's why I talked about it in this one and not in number 1. Those are good questions. Those are good questions. Lopez, we good, Lopez? Okay. All right, let's go to number 3. Number 3, this is called an argument, guys. Whatever you have inside the parentheses. So because they tell you that f of x is this, if I were to tell you give me f of happy face, you would tell me happy face squared plus 6 times happy face plus 1. And then for you happy face haters, because there's a few of you that don't like happy faces, you just go, if I were to tell you f of triangle, triangle squared plus 6 times triangle plus 1. Do we have any happy face haters in this room? Okay. I like happy faces. That's just me. So what does that mean? Guys, wherever you have an x, whatever you have in the argument is what you're going to plug in. So here's what that means. F of x minus 4 equals parenthesis x minus 4 close it squared plus 6 parenthesis x minus 4 plus 1. If this is all they wanted and they had that answer choice in there, you would just circle it. But we're going to do algebra now. Does that make sense, guys? Okay, here we go. We're just doing algebra. Okay, I guess first we'll do it slow, and then the next one we'll do it fast. X minus 4 times x minus 4. That's what that x minus 4 squared means. Plus 6 parentheses x minus 4 plus 1. Okay, let's see. X times x. X squared. X times negative 4. Negative 4x. And then negative 4 times x again. Negative 4x. And then negative 4 times negative 4. Later on, when we start doing future problems and we have a square like that, I'm just going to go negative 4 times x and negative 4x, and I'm going to say we have 2 of them, so just double it, and then negative 8x. That's later on. And then 6 times x plus 6x. 6 times negative 4. Yeah, negative 24 plus 1. I don't see any issues. I think we're okay. Let's see. Yep, I don't see. Okay, that's it, guys. We're just going to combine like terms. This is the only x squared, so x squared. This is negative 8x plus 6x, so that's going to be minus 2x, right? See? Negative 8. The difference between 8 and 6 is 2, but the 8 is negative, so we keep that sign, whichever one's larger. Let's see. Negative 21 plus 1 is negative 23, and the difference between 16 and 23 is 7, but the 23 is negative, so minus 7. So there it is. X squared minus 2x minus 7. And this individual got this one right. Do you guys like it when we go over these type of questions, or okay? I don't want to waste your time. All right. So this looks complicated. Relax. It's not. They're just telling you to do this. Later on, we're gonna add a limit to it, and we're gonna call it a tangent slope. We're not there yet. Or an instantaneous rate of change. We're not even remotely close to that. So right now, we're just going to call it an action. They want us to do f of x plus h minus f of x, and whatever that is, divided by h. This is called the difference quotient. Why the difference? Because there's a minus, and quotient because it's dividing. Cool or not cool? F of x is this guy. I do not have f of x plus h. So I'm just going to come over here, and I'm going to write f of x plus h equals, and wherever you have an x, you're going to write x plus h. Parenthesis, x plus h. Close it squared, plus 6, parenthesis, x plus h, close it, plus 3. So catch up. If you have fries, you can dip it. Oh, no one caught it. Because I said catch up. Catch up. Catch up. Okay. All right, guys. Tough crowd. Tough crowd. All right. Here we go. You see that squared? Let's see if we can do it fast. What's x times x? X squared. What's x times h? XH, but you're going to have, so we're going to double it, plus 2XH. Does everyone see where I got that? And then what's H times H? See, hopefully you can get that fast. And it's really simple to do. 6 times X, 6X, 6 times H, plus 6H, plus 3. Doesn't look like anything combines. Are we okay so far? Okay, now we're doing this. Let me see if I can write it here. F of X plus H minus f of x all over h equals f of x plus h is all this. X squared plus 2xh plus h squared plus 6x plus 6h plus 3 minus, What's f of x? Just the original equation. So I'm going to put it in parentheses. X squared plus 6x plus 3. Notice I put it in parentheses. That's your f of x there. All this is over h. So do that. And I'm going to show the steps. And the next time around, we'll see if we can take some shortcuts here. I'm going to distribute this negative. So I'm going to rewrite it again. X squared plus 2xh plus h squared plus 6x plus 6h plus 3 minus x squared minus 6x minus 3. All this is over h. I'm going to zero out where I can. I have a positive x squared. Bam. I have a negative x squared. Bam. I have a positive 6x. Bam. I have a negative 6x. Bam. I have a positive 3. Bang, bang. I have a negative 3. Bang, bang. Yeah, maybe you don't need to do those sound effects, but I've always been doing my sound effects, so it's kind of hard for me to stop now. Notice every term has an h, so I'm going to factor out an h. So here's me factoring out an h, and I'm going to have 2x plus 1h plus 6. All this is still over h. What can I cancel out? I have a product divided by h. So I can cancel out the h's on the outside. Well, the h on the outside of the numerator. So that's it. What do I have left? There it is. That's what I'm looking for. 2x plus h plus 6. It looks hard. It really isn't. If you were to give this to a 6th grader, maybe they'll cry. I don't know. So would you cry if you were a 6th grader and you saw this? But we're not crying now. Yeah, see? It's not that bad. Did I hear someone say I am crying or something? No, we're not crying. We're not crying. We're good. All right, question 5. Is it better? So what do you guys think? So the large print or the double print? What the large print is better? It's just that I didn't want to waste a lot of paper, so that's why I did the double. But maybe next time, if I have a lot of paper, I'll just, we'll see. Okay. All right, here we go, guys. Given, and they give you a graph. Which of the following statements is true? The domain of f of x is, so these are x values, negative 4 to 6. Notice they have a bracket. Well, negative 4, yep, it looks like it's definitely negative 4 to 6. So that one is true. I put a check mark. It says the range of f of x is negative 3 to 9. Those are y values. Negative 3, yep, it looks like negative 3. You don't have to have a point at negative 3. That is, that you are defining negative 3. All the way to 9. Let's see. At 9, yep, it is right there. And it's a nice continuous function, so that is true. The next one, the y-intercept of f of x is 0, 0. There's an ordered pair. That is an x comma y. So does it look like I go through the origin? Nope, I go through 0, negative 3. That's a lie. Out. F of negative 2 equals 3. That means that I have a point at negative 2 comma 3. So if you have a large print that's easier than the small print, go to negative 2 and 3. And does it look like it goes through negative 2, 3? Yes, it definitely does. Yeah, that's where the large print comes in handy on this one. If you have a small print, it might be kind of hard to tell. F of x is decreasing on the interval 0 to 4. These are x values. X equals 0. That's x equals 4. Okay, between x equals 0, here's x equals 0. And x equals 4, here's x equals 4. Does it look like you're going downhill? No, you read a graph left to right. Notice left to right, I go up. So it's increasing, not decreasing. So that one is also a lie. So what 3 are true? There it is. This person got it correct. 1, 2, and 4. So there it is. Let's go to the next one. All right. It says find the x and y intercepts of the following function, and they give you a function. The easiest one to do, guys, is the y-intercept, because the y-intercept, and I'm not drawing that graph, because obviously it's a parabola opening upward. But notice that I'm just drawing something random. Every time I cross the y-axis, the x value is 0. Do you guys see that? So I'm just going to plug in x equals 0 in there to find the y-intercept. So I just get 0, 2. That's your y-intercept. So let's see. Letter A, out. Letter B, out. Letter C, maybe. letter D maybe, and letter E maybe. So all three of those are maybes. And then the F, usually it's never none of the above. So 33% chance or 25% chance, depending on how you see it. Okay, now when you cross the x-axis, the y value is 0. See? When you cross the x-axis, the y value is 0. So here's what I'm going to do. You set 0, because this gives me all your y values. It gives you all the outputs, right? So 0 equals x squared minus 3x plus 2. And they're being nice. I have a 1 in front of that x squared. So give me two numbers that when I multiply, give me that multiply to 2, but add up to a negative 3. I'll say it again. Two numbers that when you multiply give you 2, but add up to a negative 3. Those, yeah, negative 1, negative 2. X minus 1, x minus 2. There it is. You can only do that if the coefficient in front of the x squared is 1. How do we feel? Now all we do is find where this is true. This is my y value. Bless you. Was that a sneeze? I couldn't tell. This is my y value, guys. So where is this statement true? Well, if x equals 1. See? 1 minus 1 is 0. 0 times anything is 0. Where else is it true? If x equals 2. 2 minus 2 is 0. 0 times anything is 0. So what are my x-intercepts? 1, comma 0 and 2, comma 0. So let's look for that. Out. And there it is. Letter D. Cool, right? Cool. All right. Ooh, I love this. So someone just told me that now they don't. I remember seeing. I remember this coming in the practice SAT question, the non-calculator section. But now there's not no calculator section in the SAT. It's just a calculator section. Is that true? Damn, I should have. Why have no one updated me? Okay, so there. I need to look at a rubric so I can see where we can practice. Okay. Anyways, so it says suppose that y equals f of x is an even function, and that 6 negative 5 is the point on the graph of f. Which of the points is also on the graph of f? Okay, so let's talk about even and odd. So an even function, guys, is symmetric about the y-axis. So even function is symmetric about y-axis. So that means if you fold the y-axis, it's like a mirror kind of. So if you were to fold the y-axis, if you're in quadrant 1, you're going to be in quadrant 2. If you're in quadrant 2, you're going to be in quadrant 1. And there it is. It's symmetric. It also has this property. F of negative a equals f of a. Sometimes they'll say f of negative x equals f of x. That's fine. So that's even. And then odd has this property. Odd is symmetric about origin. It doesn't necessarily have to go through the origin. If you're a function, you have to. But here's something that's symmetric about the origin. Sometimes they call it flip, flip, or fold, fold. Flip, flip. So if you're in quadrant 1, it doesn't matter. Fold it against any axis you want. So if I fold it on the y-axis, I'm in quadrant 2. Now fold it against the x-axis, you're in quadrant 3. Do you guys see that? It doesn't matter what axis you fold first, as long as you fold both of them. So if you're in quadrant 1, you're going to be in quadrant 3. If you're in quadrant 2, you're going to be in quadrant 4. If you're in quadrant 3, you're going to be in quadrant 1. If you're in quadrant 4, you're going to be in quadrant 2. Did I mention all of them? I think we got them all. Sometimes they'll say this. F of negative a equals negative f of a. Or f of negative x equals negative f of x. All right. I think we're good. Let's see. This is an even function, so I'm going to put a point. I already have a grid here, so I'm just going to go 6, negative 5. Boom. So 6, negative 5, fold the y-axis. Where are you going to be at? Quadrant 3. What's that coordinate? There you go. See? If it was an odd, tell me where I would be. Flip, flip. Where would I be? I'd be in the same quadrant. Where would that point be now? Yep. If you were odd. So put that in for good notes. Cool or not cool? All right. Yeah, we can go a lot slower now because yesterday we were going fast. Ask me. No, hit me. I want you to ask. Oh, okay. Okay. Determine whether the following function is even, odd, both, or neither. Okay, it's never going to be both. So delete letter A. It's possible it could be neither. Now you can have tendencies of both. Well, okay, let's not get into that because we're not there yet. We're not talking about end behavior or any of that. See if we have wiggles or jumps or. Okay, anyways, let's just talk about this one. So what do we know? Look, I'm seeing both powers and they both look odd. So what do I know about odd? I'm not saying that it is odd, but remember that we have this property f of negative x equals negative f of x. You could also test it, like pick a point and see if, and then pick it. Let's just do it one way. All right, here we go. So I'm going to insert negative x, f of negative x equals 6 parentheses negative x to the fifth minus 3 parentheses negative x to the third. And look what happens. Negative x to the fifth, negative times the negative times the negative times the negative times the negative is going to be a negative. So it's going to be negative 6x to the fifth. And then negative x to the third, negative times the negative times the negative is going to be a negative. Negative times the negative is a positive. And then if I factor out a negative, 6x to the fifth minus 3x cubed. OMG, this is f of x. See? So what I have here, I have f of negative x equals negative f of x. Is that an odd property? Yeah, it's odd. You could have also done it like this. In case you don't like it, we're going to give you several ways. If I plug in a 1, I get 6 minus 3, which is 3. So if it's odd, if I plug in a negative 1, I better get a negative 3. Let's see. Negative 1. Negative 1 to the fifth is negative. Negative times the positive is a negative. Negative 1 to the third is a negative. Negative times negative is a positive. So I have negative 6 plus 3. That's going to be a negative 3. Yep, look at that. Odd property. Cool or not cool? Okay. These are some of the easier ones. F of x equals x squared. That 5/2 is a vertical stretch. Vertical stretch by factor of 5/2. Either a stretch or compressed, but it's bigger than 1, so it's a stretch. And that x minus 6 is a horizontal shift. Horizontal shift. How many times? 6 right. Perfect. And then that plus 2 is a vertical shift. Vertical shift up 2. And we just look for that. And letter C. How are we feeling, guys? Nothing crazy, right? Okay. Let's go to the next one. I don't like the way this is worded, but I know what they're trying to say. So let me tell you to you guys in plain English what they're trying to say. State the translation point of the key point 0, 0. So they're saying this. They have a function. It's a square root function. This is the parent function. And the square root of x starts at 0, 0. They call that an endpoint. So that endpoint, that 0, 0, they want to know where does it go now. So all I got to do, make it look like this. Make this function look like x minus h plus k. So notice, or I guess in plain English, make it look like square root x minus h plus k. Make it look like that. I need that x to be positive, so I'm going to factor out a negative. So f of x equals square root negative parenthesis x minus 3, and then outside that parenthesis minus 6. So there it is. So I move 3 to the right and 6 down. By the way, in case you're wondering, that negative makes it open to the left. So if you want a visual, let's see. Here's my visual. 6 down. I said 6 down. I didn't put a negative. 3 to the right. Did I say 3 to the left? 3 to the right and 6 down. Man. So here I am. 3 negative 6, and I didn't draw it to scale. Not to scale. I probably exaggerated it, but something like that. It opens to the left. Any questions, guys? Yeah, I'm going to go back to the video and see if I said what I said correctly. I think I did not say it initially correctly, but I fixed it. How do we feel? Okay, here we go. Question 11. Suppose the point 2, 4 lies on the graph of the function f of x If the function is transformed as 3 f of x plus 4 plus 6, which of these coordinates which will be the coordinates of 2, 4 under the transformation? Okay, this 3 is a vertical stretch. It affects, what does it affect? The x or the y value? Just the y value. Vertical stretch. So I'm going to put y. This is a horizontal shift. I'm just going to write horizontal HS, and it affects your x. And that plus 6 is a vertical shift. It affects your y. So let me rewrite it. 3f of x plus 4 plus 6. Okay, what do you do first? 1, do horizontal shift first. Okay, well, I was at 2. I am moving 4 times to the, no, not to the right. It says plus 4. To the left. So if I'm moving 4 times to the left, what's my new coordinate? -2. So I'm going to write, take that 2 and subtract 4. 4 left. Okay, now we're going to worry about the y value. So second, do multiply. I'm just going to write the word multi. Do vertical stretch. So when you read my direction and it says multi, like, oh, okay, we're going to multiply that vertical stretch. So take the y value, 4. So I'm going to go 4. That's this y value. And I'm going to multiply it by the vertical stretch. So what's 4 times 3? And then the last step, and it's in combination with 2, add vertical shift to y. All right, my vertical shift was 6. So 4 times 3 is 12. What's 12 plus 6? Yeah. That's the number you're going to put right here. This person almost had it right. She at least knew it was -2, so she took out all the ones that don't have a -2 for x coordinate. See? So close. So close. Cool or not cool? All right. Question 12. Hopefully everyone gets these questions correct. Number 12. This is a straightforward one, guys. What's the output when x is 4 for f? What's the output when x is 6 for g? So I go to f and I go to 4, and it looks like it's -2. Plus, I go to 6 and I go to g, and it looks like it's 5. -2 plus 5 is 3, or same thing as 5 minus 2. And I look for that. Let's go to the next. It says, given f of x and g of x, find the domain of f over g. All right. Check it out, Zamora. Did I call, that's your name, right? Okay. Because you gave me a look like, maybe I caught you off guard. Sorry, miss. All right. So check it out. Do I have to worry about the numerator? No, because it's all real numbers for the numerator. So all I got to do is focus on the denominator. Do you guys see that? You cannot have a 0 in the denominator. So I'm going to factor out x squared plus x minus 30. What two numbers multiply to give you -30 that add up to a positive 1? 5 and 6. Which one's positive? Which one's negative? Yep. There it is. And I just don't want this to equal 0. So I get x equals -6. These are numbers you cannot be. And x equals 5. These are numbers you cannot be. So I'm going to go from -infinity all the way. You go left to right, all the way to -6. Then union from -6 all the way to 5. Then union from 5 all the way to infinity. So there it is, all real numbers except -6 and 5. And I look for that. And there it is. I know, not the most exciting stuff in the world. All right, on the next one, question 14. That open circle means composite or composition. Child, what does that mean? What does composition mean? Hopefully you remember. G composite of f at -1. That's what all it means. So I look at f of negative 1 first. You evaluate these from the inside going out. F of negative 1, I go to negative 1. F of negative 1 looks to be, to me, it looks like it's 3. So I'm going to write f of negative 1 equals 3. If you have a smaller one, a smaller print, you might not see that. So I'm going to plug in 3 in for g. G of 3. So I'll go to 3, 1, 2, 3, and I go to g, and it looks like it is 6. So there it is, and I look for 6, and that's my answer. We're doing okay so far, guys? All right, last one, or not the last one. We're almost there, though. This starts picking up. This says f composite of g. It's open circle. So f composite of g, sometimes people call this fog. Don't call it fog. F composite of g means f composite of g. See? So what is g of x? 3x minus 3. So I'm going to write f of 3x minus 3 equals, and wherever you have an x, you're going to plug in 3x minus 3. Parenthesis, 3x minus 3, close it, squared, plus 3 times 3x minus 3. We're going to get a chance to practice our algebra skills, see if we can go fast. What's 3x times 3x? 9x squared, right? 3x times 3x. What is 3x times negative 3? Negative 9x, but you're going to have two of them, so double that. Minus 18x. Do you guys see how we did it? What is negative 3 times negative 3? Negative 3 times negative 3? 9. There it is. We just did it without. If you want to go to the side, 3x minus 3, 3x minus 3, that's fine. But try and get in the habit of being fast, if you can. 3 times 3x, 9x. And then 3 times negative 3, negative 9. Combine like terms. There's only one 9x squared. Let's see, negative 18x plus 9x, that's going to be a minus 9x. And then the 9's zero out. So there it is. We're doing okay so far, guys? All right, question 16. This says G composite of f of 3. Evaluate f of 3 first. Evaluate f of 3 first. So 3 plus 3, so I got 6. So now I'm going to plug that 6 into G. Does that make sense, guys? So G of 6 equals 4 times 6 minus 2 times 6 squared. Chop, I need a calculator. You don't need a calculator. 4 times 6 is 24. 6 squared is 36. Double of 36. Well, let's see. If it was 35, it'd be 70. So it must be 72. See? Well, I do it in little pieces. Maybe your brain is wired different and you can just do it all in one. And then I just do the difference between 24 and 72. That's 48. The 72 is larger, so negative 48. And there it is. I look for that answer, and this person got it right. Do you remember what one-to-one function means? It's okay if you don't. It means that every x has a y, every y has an x. A unique x. Every unique x has a unique y, every unique y has a unique x. So what that means is passes vertical and horizontal line test. Child, what does that mean? That means if I have a curve, if I draw a vertical line, it only crosses it once. If I draw a horizontal line, it only crosses it once. Does that make sense, guys? Okay, check it out. Number 1, it's a parabola. Child, how do you know it's a parabola? I see an x squared. Are parabolas one-to-one? Be careful. They do pass a vertical line test, but do they pass a horizontal line test? No, it crosses it more than once. So that one's out. Roman numeral 2, is that one a parabola also? What do you guys think? Oh, I don't know, child. It has an x plus 3 with a square on it. It is a parabola, guys. If you were to expand it, you'll have an x squared. So that's a parabola also. So that one is also not one-to-one. What about Roman numeral 3? It's a cubic. Child, I don't know how cubics look. It just has a cubic and it's just vertical shift with a vertical stretch, but it all looks like this. All cubics look like that. So is that one one-to-one? Yeah, it passes vertical and horizontal line tests. Check mark. What about the absolute value one? All absolute values look like this, all of them. Well, they don't have a wiggly there, but why am I writing a wiggly? Okay, there we go. Yeah, they don't. It doesn't pass a horizontal line test. So what's the only one? Letter D. It's not the machine that's doing the wiggly. It's me. My little hand, or it's not a little hand, but my hand is doing a little curl up. All right. Given the following table, all right, this means inverse. Inverse of f. I guess I should say. Means inverse of f of x. So what do we know about inverses? So real quick, just so we can make sure that we know, inverses reflect across the line y equals x. If you have a point, I'm trying to reflect it across that. If I have a point there, a comma b, then I'll be over here at b comma a. So now that you know that, that 3 was a y value on f of x. I come over here and I look for the y value of 3 and I see it right there. So f negative 1 of 3 is going to give you, what is it going to give you? Negative 5. And that's it. How do we feel, guys? Okay. Don't worry. We'll figure this out really quick. So f and g are inverses of each other. So that means that g is the inverse of f. So there it is. So I have a point, negative 1 comma 5. I have another point, 5 comma 3. This is f of x. So that means this is from your f of x graph. So f of 5 equals 3, f of negative 1 equals, so they want to know, what do they want to know? F of negative 1 of 5 equals, well, that 5 was a y value on the original. So there it is. So I'm looking at this one. What is it going to give me? Negative what? Negative 1. That's it. We're okay, guys? Okay, here we go. Let's go to the next one. Find the inverse. Okay, because it reflects across the line y equals x, I can just switch the x and the y. And I know it's not, we're almost done, guys. We're almost done. I'm going to write it like this. X equals 5y plus 6 over y minus 2. So catch up to here. All right, first move. I'm trying to solve for y, so I got to get rid of that y minus 2. So multiply this by y minus 2. Whatever you do to one side, you do to the other. When you do that, bam, bam, those go away. And distribute this. So you're going to have xy minus 2x equals 5y plus 6. Your next move, you want to move the y's to one side. So I'm going to move that 5y to the left, and I'm going to move that negative 2x to the right. You want to group the y's because you're trying to factor that out. So, or you're trying to get y by itself, that's why. Xy minus 5y equals 2x plus 6. I don't see any issues. I think we're okay so far. Next move, I'm going to factor out a y. So I'm going to write y, parenthesis, x minus 5, close it, equals 2x plus 6. Next, this is a product. I want to get rid of that x minus 5. Divide, divide. So y equals 2x plus 6 over x minus 5. And then finally, just write that y as f of negative 1. F of negative 1x, that just means inverse x. 2x plus 6 over x minus 5. And there it is, guys. How do we feel, guys? Do we feel okay? Okay, I'm going to do this one the right way, and then I'll tell you a hack. Don't worry, we're almost done. We just got 5 questions left. Hang in there, guys. We just got 5 more, and we're done. All right, I know. This is kind of brutal, but we're almost there. So use the property of inverse function to determine which of the given functions. Okay, so I only see one that has a slope of 6, and I see 2 that have a slope of 1, 6. One's positive, one's negative. Maybe that's a hint right there. So I'm going to take the first equation. I'm going to go x equals 6y minus 1, and I'm going to solve for y. So I'm going to move that 1 to the other side, and I'm going to write x plus 1 equals 6y. And I'm going to divide everything by 6. Divide by 6, divide by 6, divide by 6. So what do I have? I have f of negative 1 of x equals 1 6x plus 1 6. And I'll slow down. I start looking for that equation. And it looks like here it is. Okay, let me give you the hack for those that want to be fast. You see how this slope was 6? Real quick, I guess a side note over here. I'll put it over here. If your slope is always going to be always changing y over changing x. When we take the inverse, remember that y equals x. You will reflect across that line y equals x. Then your slope turns into changing x over changing y. Your slope turns into the reciprocal. Not opposite reciprocal, just reciprocal. So I have a slope of 6. I should be looking for a slope of positive 1 6. This is the only one that has a slope of positive 1 6. The other one's negative. The other one's perpendicular, not inverse. Does that make sense, guys? That's the hack if you were trying to be fast. There it is, F and H. Why did that sound like you were saying a bad word or something? F and H. Okay, I'll stop. SMH, F and H, SMH. Okay, whatever. All right, direct substitution, guys. Direct sub. That's all you're doing. Wherever there's an x, plug in negative 3p. So you're going to go, I have a lot more room down here, so I'm going to go down here. I'm going to go negative 3p squared, put that in parentheses, negative 3p plus 1 minus a negative 3p. All right, negative 3p times negative 3p, that is a 9p squared. See? And then there's nothing in front of the parentheses, so you could just do what Snoop Dogg says and drop it like it's hot. And then, do you guys know who Snoop Dogg is? Maybe I'm too old and you guys don't know. Okay, yeah. He created that he was in the studio, and I think he had hot chocolate, and he dropped it. It's like, oh, I dropped it because it was hot. And it's been a hit single ever since. And by the way, I made that story up, guys. don't quote me, and like I know how he got that line. I totally made it up right now, so don't believe. I bet some of you were probably believing. It was a joke, 100%. I did not know he was at the Olympics, but that's cool. That's cool. And yeah, so now I'm looking for that, guys. A's out, B's out because they have the negative in the front. C's out. Oh yeah. Okay, I was already getting worried. Letter E. All right, here we go. We got 3 left. 23, 24, and 25. This is going to be heavy algebra. Relax. So f of x plus h is 4 over parenthesis x plus h, close it, plus 3. But again, we reference Snoop Dogg. We can just drop them. X plus h plus 3. Because there's nothing in front of the x. So there it is. Now we're going to do this expression. For the sake of having space, I'm just going to put a circle and put equals immediately. F of x plus h is 4 over x plus h plus 3 minus f of x, which is 4 over x plus 3. And all this is divided by h. Common denominator. I'm going to multiply this guy over here by x plus h plus 3 over x plus h plus 3. And I'm going to multiply the left term over here by x plus 3 over x plus 3. When you do that, and I'll slow down, does everyone know why I had to do common denominator? Because that's the only way that we can subtract them. And I know it's hard. It's hard to do math after math class, especially if you're not sleeping right. Your eyes are probably getting so heavy. But hang in with me. We just got 3 more, guys, and then we'll be done. I know it's hard to do math after lunch. I know. Trust me, I know, guys. 4 times x is 4x. 4 times 3 is 12. And I'm not going to distribute the bottom. I'm going to leave it at s plus 3, x plus h plus 3. Minus 4x plus 4h plus 12 over x plus 3, x plus h plus 3, plus 3. And then all this is still over h. Okay, one last line here. And then we'll start combining like terms. Put a parenthesis around that to help you out when you're distributing that negative there. So 4x plus 12 minus 4x minus 4h minus 12. All this is over x plus 3, x plus h plus 3, and then put the h right next to it. Boop. So, sorry, I got that little boop sound. There's a channel that I follow on YouTube. I can't remember the name of it, but it's a lady that has a whole bunch of lions and tigers, like big cat sanctuary, and she always boops her nose. She's like boop, boop, and now she got me saying it because I watch her videos all the time. Yeah, YouTube knows me so well. This is why I can't have TikTok, because if I download it, like I'll just keep getting animals upon animals, and I'll never. Okay, I'll stop. I love animals. Hopefully you do too. All right, what's gonna zero out? Yeah, the 4x's. Bam. And then what else is gonna zero out? The 12s. And now that I've canceled all those out, I have a 4h left, and these h's cancel out. Do you guys see that? So there it is. All I have left is negative 4 over x plus 3, x plus h plus 3. And before you comment, sir, there's no negative 4. Relax. The negative's in the very front. But if you have a small print, you probably won't see it. Nope. Maybe. Nope. Nope. And that one's positive. Nope. It's letter B. All right. Last two. I think it's easier to visualize. But the last period said, no, just plug in x minus 2 into it and see what that y-intercept is at the very end. I don't know. Do you guys want me to do it that way? I think it's more work, but they want to know the y-intercept of this function. So let's see what that function is. 4 parenthesis x minus 2 close it squared plus 6 parenthesis x minus 2 close it plus 2. I guess it gives us an opportunity to practice. 4 parenthesis, what's x times x? X squared. X times negative 2? Negative 2x, but you're going to have how many of them? 2, so I'm going to write negative 4x, and then negative 2 times negative 2 plus 4. Make sure you put a plus 4 there. Plus 6x minus 12 plus 2. Distribute the 4. You don't have to do the sound effects. That's just me. 4x squared minus 16x plus 16 plus 6x minus 10 when I combine those two. All right, let's see. There is no other 4x squared, so that's the only one. Negative 16x plus 6x, that's minus 10x. And then 16 minus 10, that's plus 6. If I insert the x equals 0, there is my y-intercept. There it is. You want to see another way, guys? Okay. I think that's a lot of work. I think this is what I just would have done. So don't write anything down, just listen. I have a grid. How is this f of x minus 2 compared to f of x? Yeah, this one here is this original one moved twice to the right. Does that make sense? So if I move this function twice to the right, that means wherever I was at negative 2, when I move twice to the right, I'm going to be right on the y-axis. Does that make sense, guys? So I'm just going to insert negative 2 in here. So watch, f of negative 2, 4 times negative 2 squared plus 6 times negative 2 plus 2. And whatever that spits out is my y-intercept. Negative 2 squared is 4. 4 times 4 is 16. 6 times negative 2, that's negative 12, plus 2. Look, 16 minus 12, what's that? 4 plus 2, 6. OMG, there it is. I think that's easier. But, whatever floats your boat. How many of you have boats? Do your boats float? Okay, sorry. Last one. And then we'll call it a day. Find the linear function f. Notice they want f. And they give us this. That is a point on the inverse, but they're being nice. Both the x and y are the same. I wonder why they're being nice. On this one here, these are not the same. Let's write f the inverse one. 7, negative 3. These are on your inverse graph. On inverse. They don't want the inverse graph. They want the original. So on f of x you have these points. You have negative 1, and what's the other point on f of x? Not 7, -3, but -3, 7. So I'm going to find my slope. Slope is just y2 minus y1 over x2 minus x1. So let's see, if I call this x1 comma y1, and I call this x2 comma y2, so here we go. 7 minus a -1 over -3 minus a -1. So 7 minus a -1, that's 8. 3 minus a -1, that's going to turn to a positive, so that's going to be a -2. Positive divided by negative is a negative, so my slope is -4. I only see one answer that has a -4, but I want to do it the right way. I'm going to use my point slope formula. Use point slope. Point slope is what? Y minus y1 equals slope x minus x1. So I called x1, y1 this one. So I'm going to use that. It doesn't matter. You can actually use the other one and you get the same answer. Y minus a -1, so y plus 1 equals slope, -4, x plus 1 minus a negative. Distribute. Y plus 1 equals -4x minus 4. Subtract 1, subtract 1. Y equals -4x minus 5. OMG. That's the same. Cool or not cool? So we have done all the questions. You have until Wednesday to get 100. Do you think that's enough time? I recommend, I know we only have 10 minutes. I recommend that you make an attempt sometime tonight at home. That way you can come ask me questions on whatever questions you're getting wrong. Don't ask me while you're live. I prefer that you do it on your own, guys, because it is a test grade. But I know that outside, once you leave these doors, I know that there might be some dishonesty. I can't control that, so that's on you. But remember, this is going to be tested on the 9-week test, so it's not to your benefit. But it is what it is. Whatever question you don't know how to do, come ask me. Don't ask me while you're live, because then I'm giving you the answer. But ask me after the fact. Cool? And you can ask me as many times as you want. You take it 10 times, take it 10 times, take it 20 times, take it 20 times. Is everything fair? Is everything cool? What's up? Wednesday. I guess if you want a time, I usually start putting in grades somewhere between 9 and 10 p.m. But sometimes if I'm real tired, I just won't do it until Thursday morning. So depending, I prefer, I don't want, and by the way, I saw some of the Delta logs, and some of you guys are on it at midnight. Guys, I really don't want you guys doing problems at midnight. I really do. Okay. Let me stop recording because then everyone's gonna, okay. Let me